Hello, this is Dr. Brown. In this chapter, we're going to look at trigonometric functions in a slightly different way, called the unit circle approach. Some of the items we're going to be covering are how to find the exact values of the trig functions using the unit circle approach. And then we're going to understand what the domain and range of the trig functions are. That really means what values can you put in for the angle theta in the trig functions, and how large or small can the values of the trig functions be. Then we're going to see that the trig functions repeat themselves and have what we call periodic properties, and we're going to use these properties to find the exact values of the trig functions. And then we're going to also see that the trig functions are either odd or even, and we're going to use these understandings to find the exact value of the trigonometric functions. So we're going to first start out with finding the exact values of trig functions using the unit circle. And a unit circle is about what you might think. It's a circle with a radius of 1. And we set all this up by thinking of a line in which we have the unit t, and t can go from 0 to infinity, or from 0 to minus infinity. And what we do is we take this line and wrap it around the unit circle, and where, for a given t, the end of the line wrapped around the circle would fall at a point we're going to call A and B. And notice that for t more than 0, the arc length is going to be r times theta, which in this case r is 1, so the angle theta is going to be equal to t, and the arc length would be equal to the absolute value of t. Notice for the unit circle, we can draw a triangle for the point A and B, and the opposite would be B, and the adjacent would be A. And we can now define the trig functions in terms of the A's and the B's. The sine function of t would be equal to the opposite over the hypotenuse, which is b. The cosine would be the adjacent over hypotenuse, and since the hypotenuse is 1, it would be a. The tangent function would be opposite over adjacent, which would be b over a. The cosecant, remember, is the reciprocal of the sine, which is 1 over b. The secant is the reciprocal of the cosine function, which is 1 over a, and the cotangent of t would be the reciprocal of the tangent, which would be a over b. Now we want to find the values for this point on the unit circle, which is minus a half the square root of 3 over 2. And we want to find the values of all the trig functions. So just following along with the definitions, for the point minus a half in the square root of 3 over 2, therefore a is minus 1/2 and b is the square root of 3 over 2. We can then define the sine function is equal to b, which is the square root of 3 over 2. The cosine is equal to a, which is equal to minus a half. And then the tangent function would be b over a, which is the square root of 3 over 2 divided by minus 1/2, which simplified would be minus the square root of 3. The cosecant is simply 1 over b, or the reciprocal of the sine. Reciprocal of the sine, which would be 2 divided by the square root of 3, simplifying that and rationalizing the denominator, we get 2 square roots of 3 over 3. The secant would be 1 over the cosine, which is 1 over minus a half, equal minus 2. The cotangent would be the reciprocal of the tangent, which is minus 1 over the square root of 3. And that equals minus the square root of 3 over 3. And so there are the trig functions of a point on a unit circle given here. Now, as we notice, if t is the arc length on the unit circle, that also corresponds to the angle theta. So theta equals t. And so we can simply say sine of theta is sine of t, cosine of theta is cosine of t, all the way through cotangent of theta is cosine of t. Now, we could also define a circle that's not a unit circle and has a radius of r. And here, instead of x squared plus y squared equals 1 for a unit circle, we have x squared plus y squared equal r squared. And we still can talk about a point A and B on the circle that's not a unit circle. And now, looking at this, the sine of theta would be not just b, but b over r, because that's the opposite over the adjacent. In fact, let's draw this angle theta, radius r, point A and B. This would be B and this would be A. I always draw something like this so I can remember what I call the fundamental definitions with respect to a right triangle. And so we can get sine of theta is b over r, opposite over the adjacent. Cosine of theta is adjacent over the hypotenuse. The tangent of theta is opposite over adjacent, which is b over a. Cosecant of theta is a reciprocal of sine, which would be r over b. Secant theta is a reciprocal of cosine, which would be r over a. And cotangent of theta is a reciprocal of the tangent, which is a over b. Here's an example of a 45-degree angle on a circle that's not a unit circle. Here it has A as 1 and B as 1. This would obviously be a 45-degree triangle. And the A being 1 and the B being 1, then R would be the square root of 1 squared plus 1 squared equal the square root of 2. We can also set up a 30 and 60 degree triangle in which the radius is 2, A is the square root of 3, and B is 1. And then if we have a 60 degree triangle, the A would be 1 and the B would be the square root of 3, and the radius would be 2. Now let's just do an example of finding exact values of the 6 trig functions if the point on the non-unit circle is 4 and minus 3. Notice R would be the square root of A squared plus B squared equals 16 plus 9 equals square root of 25 equal 5. So now we're going to have a non-unit circle with a radius of 5. So we plot the point down here, 4 and minus 3, and the sine of theta is b over r minus 3/5. Cosine of theta is a over r, which is 4/5. Tangent of theta is b over a, which is minus 3/4. Cosecant theta is the reciprocal of sine, so just flip it over and we get minus 5/3. Secant of theta is the reciprocal of cosine. Flip that over and we get 5/4. Cotangent of theta is the reciprocal of tangent, which is minus 4/3. Now we want to talk about the domain and range of the trig functions. First, let's see what constraints we might have on theta. Here are the definitions for the unit circle for theta. And notice that for sine of theta is always equal to b. So theta can be anywhere between infinity and minus infinity. We could start at 0, go around to 2 pi, to 4 pi, 6 pi, all the way around, keep on going towards infinity, approaching infinity. We could also go counterclockwise, 0 to minus 2 pi to minus 4 pi. So the domain of the sine function is minus infinity to plus infinity are all real numbers. Notice for cosine, the cosine is always equal to a. And so the cosine of theta can also be between plus infinity and minus infinity. Go around and around and around, and we keep generating A's and B's, and sine and cosine have no constraints on the theta value. However, for tangent, notice that the tangent is equal to B divided by A, so A can never be 0. Well, if A can never be 0, that means we can't have this angle, which is pi over 2. We can't have this angle, which is 3 pi over 2. And we keep going around and around, and we do not want any odd multiple of pi over 2 for tangent. Now, cosecant of theta is equal to 1 over b, and so theta can be between infinity and minus infinity, except if the value makes b equal to 0. If b equals 0, then that would be 0 for the angle. Pi for the angle gives b equals 0. Or multiples of pi. So we can't have 0 pi, 2 pi, 3 pi, 4 pi, etc. So any multiple pi is forbidden. Now, for secant, everything is fine except when a equals 0. So when a equals 0, that rules out no pi over 2, 3 pi over 2, or odd multiples. And then finally, for cotangent, b can't be 0. So again, just like for cosecant, we cannot have b equals 0, so it can't have any multiples of pi. So the next page summarizes this. The domain of the sine function is a set of all real numbers. The domain of the cosine function is a set of all real numbers. The domain of the tangent function is a set of all real numbers except odd multiples of pi over 2. And the domain of the secant function is a set of all real numbers except odd integer multiples of pi over 2. And the domain of the cotangent function is a set of all real numbers except for integer multiples of pi. And the same goes for the cosecant function. And all real numbers except integer multiples of pi. Now, how big can the sine function and the cosine function get? Well, we can go back to the definition of the sine function and the cosine function. Notice that if you go around a unit circle, the largest a can be is 1, and the smallest it can be is -1. And so that means that both cosine and sine have to be between -1 and +1. So sine of theta is less than or equal to 1, more than or equal to -1. Can never get bigger than that. Notice that since cosecant and secant are equal to 1 over b and 1 over a, that cosecant of theta is more than or equal to 1, and cosecant of theta is less than or equal to -1. So it could go from -infinity to -1 and from 1 to infinity. And the same goes for the secant function. Notice that for the tangent and cotangent functions, a and b can get very small, and so they can go from 0 to infinity and 0 to -infinity. So here we have the sine and cosine can never get bigger than -1, or smaller than -1, or bigger than +1. Cosecant has got to be more than or equal to 1, less than or equal to -1. Again, the secant has got to be less than or equal to -1, or more than or equal to 1. And then the tangent functions can go between -infinity and +infinity. This is just a table with the domain and range of all the sine and cosine functions. Tangent, cotangent, secant, and cosecant. Now, notice that as you go around and around the unit circle, the values of the trig functions repeat. So they have periodic properties. If you started at a given point on the unit circle, like pi over 3, if you went pi over 3 plus 2 pi, you're back at the same point. In fact, for any value of theta that gives you a point on the unit circle A and B, go plus 2 pi, minus 2 pi, keep going around and around. It keeps repeating the values. So we come out with the fact that the sine of theta plus 2k pi is equal to sine of theta. cosine of theta plus 2k pi is equal to cosine of theta, where k is any integer. So the period of the sine function, cosine function, is 2 pi. So here's a definition of a periodic function. A function f is called periodic if there is a positive number p such that whenever theta is in the domain of f, so is theta plus p. And f of theta plus p equal f of theta. And if there is a smallest such number, the smallest value is called the fundamental period of f. Now, the fundamental period of sine and cosine is 2 pi. But notice, for tangent and cotangent, the fundamental period is not going to be 2 pi. It's going to be less than that because, remember, tangent of theta is equal to b over a, and cotangent of theta is equal to a over b. So if you start at a point P, A and B, and go pi, which is 180 degrees, you have minus A and minus B, and B over A would still be the same. So the period of tangent and cotangent is pi. So here are periodic properties. For sine, cosecant, cosine, and secant, the period is 2 pi, or the fundamental period is 2 pi. And for the tangent and the cotangent, because of the definition of a tangent and cotangent, the period is pi. Now, I don't think that using the periodic properties to find exact values is necessarily something that you'll always have to do, because you can always plug these into your calculator, and your calculator will take care of the periodic nature. But let's calculate sine of 420, tangent of 5 pi over 4, cosine of 11 pi over 4. And notice, sine of 420 is equal to 60 plus 360. So 360 is the period. So this would be sine of 60, which we know to be the square root of 3 over 2. However, notice I'm going to put this in the degree mode. I'm going to show you that if we calculate sine of 420, it will calculate the value correctly. We get 0.866, which is the square root of 3 over 2. Same token, tangent of 5 pi over 4. Remember, the period of pi is, the period of tangent is pi. So this is equal to pi over 4 plus pi. So since pi is a period, we can just take the tangent of pi over 4, which is 1. The calculator would have given you that also. Cosine 11 pi over 4. Notice that the period of cosine is 2 pi. So we can break 11 pi over 4 into 3 pi over 4 and 8 pi over 4. Notice 8 pi over 4 is 2 pi. That's the fundamental period of cosine. So if we take cosine of 3 pi over 4, we will get the answer, which is minus the square root of 2 over 2. The calculator would have given you that exactly also. Notice that the sine function is an odd function. And you can see that if you go to theta, which has a point A and B on the unit circle, and go to minus theta, which has a point A and minus B, that the sine of minus theta is minus the sine of theta. By the same token, we see that for theta and minus theta for cosine, that they have the same value, A and A. So cosine of minus theta is equal to cosine of theta. And notice that since tangent is equal to the B over A, that for minus theta, the tangent of minus theta happens to be the negative of tangent of theta. And you can keep doing this since the cosecant is equal to the reciprocal of sine. The cosecant of minus theta is going to be minus the cosecant of theta. And since secant is the reciprocal of cosine, secant of minus theta is going to equal to secant of theta. And since the cotangent is the reciprocal of tangent, cotangent of minus theta is equal to minus cotangent of theta. Find exact values using the even and odd properties. By the way, you can plug these in, and it is okay on a quiz to do this. I may ask you something about the even and odd properties, but generally you won't think of even and odd properties when you're doing trig. But to work these, sine of minus 45 degrees, since it's an odd function, is equal to minus sine of 45, which is minus the square root of 3 over 2. Cosine of minus pi is equal to cosine of pi because it's an even function. So it's cosine of pi is minus 1. Cotangent of minus 3 pi over 2, since it's an odd function, is minus cosine of 3 pi over 2, which is 0. And then finally, tangent, which is an odd function, is minus tangent of 37 pi over 4. Notice you could plug this right in your calculator, or you could see that that is 9 periods of pi plus pi over 4. So it's going to be minus tangent of pi over 4, which is minus 1. And that is the lesson for today.